So in the previous video, we talked about how voice over IP is incredibly convenient, it's incredibly powerful, but because it uses the Internet Protocol as its transport, it opens itself up to many security vulnerabilities and risks that, as security researchers and as security professionals, we have to understand these vulnerabilities and just accept that this is the way the internet is. And so how do we then insulate ourselves from this, maybe using encryption or using other tools to help us be more secure on the internet and secure our data? So in this video, we're going to be talking about the solutions to those key threats in voice over IP. Those key threats at the network level, the protocol exploits, the fraud and abuse, the insider and configuration risks. All of these things can come into play and can be threatening to your voice over IP data. So using these solutions is what's going to help insulate yourself from these. And this is what I have learned over my time of studying this. And so let's go over the key security, the core security mechanisms or security solutions. So number one is going to be encryption. So for signaling, SIP over TLS secures call setup messages. So that's really important. For media, since we use RTP in voice over IP, we use RTP to actually transmit that voice data. We're going to use secure RTP. Secure RTP, or also known as SRTP, because it encrypts. It encrypts the voice and video stream. All right, it encrypts it. So, and that will solve the eavesdropping the eavesdropping threat here. Eavesdropping is packet sniffing unencrypted RTP streams. Well, okay, fine. We'll use SRTP, and then there you go. Have fun trying to unencrypt it and find out what I just said. And that's sarcasm. All right, and then key exchange, DTLS, SRTP, SDES, or the Zimmerman RTP to handle session key negotiation. Okay, so that's encryption. Now we go to authentication and access control. All right, so strong SIP authentication. Like OAuth now is used in modern unified communication systems. Multi-factor authentication for admin access. So, and what is multi-factor authentication? In case you don't know, it's where you authenticate once and they send you an email, they send you a text message to authenticate yourself in another way. That would be like two-factor authentication, and then multi would be, there's more than two ways to authenticate yourself when you log in or something, especially as an admin. Maybe you'd have the email, and then you'd have like an authentication app that would send you a number, and then you have to type that number in. So there'd be three ways you would be authenticating yourself to log in as an admin. And then session border controllers enforcing per user, per trunk policies. All right. So we'll get into session border controllers here too. Firewalls and SBCs. Okay. Session border controllers. Session border controllers provide NAT traversal, denial of service protection, topology hiding, and SIP normalization. Firewalls, VoIP aware firewalls prevent unauthorized traffic while allowing SIP RTP. All right. So firewalls are using rules, right? Uh, preventing unauthorized traffic. So there's just a rule there that says, okay, this traffic is allowed, this traffic isn't allowed. Or it'd be something like this traffic is allowed and then everything else isn't. And that'd be the rule. And so that's what the firewall would use. Monitoring and intrusion prevention. Oops, sorry. Sorry about that. Monitoring and intrusion prevention. All right. IDS and intrusion detection system and intrusion prevention systems with VoIP rule sets. Rule sets like snort, SIP aware monitoring for fraud detection. All right. All right. So now we go into like let's just talk about best practices, right? We don't even need to take a note on this. Let's just talk about best practices, right? Encrypting everything is pretty important. Okay, that can insulate you from these key threats. Encrypt everything. Use SRTP. Use SIP over TLS. Um, you know, that is going to be the foundation of defense against these things like eavesdropping. If the data can't be used because it's encrypted, then who cares if they have it? Um, so that's kind of where it starts. Then segmenting the networks, using VoIP VLANs, separate from data, using SBCs as gatekeepers, strong authentication and rate limiting. These things are the foundation of how we secure our VoIP data. So, with that, I think I'll stop here and I will go in the next one. We'll talk about maybe some examples. So thank you.